Alright, so let me show you how to use this. I want to expand, instead of a plus b, I'm going to kick it up a notch to do 2x minus y raised to the fourth. So there's going to be 5 terms because of the pattern we observed, so I'll give myself 5 blanks. 1, 2, 3, 4, 5 blanks, and this time I'm going to recognize that I do no longer have an a here, so this whole term, 2x, will take the place of a, and this term minus y will take the place of b. So we'll have to keep that in mind as we follow our pattern. So the first term is going to be the first term a raised to the max, but our first term is a 2x. So I'll take the 2x and raise it to the fourth, and then I will put in the coefficient from Pascal's triangle. That'll be the line with 1, 2, 3, 4, 5 blanks. Here it is, right here. So I see the coefficient always on the first and last is a 1. So I don't have to write it, but I'll put it in for just so we see the pattern developing. Then the second term is negative, the b that takes the place of the b is negative y, and it will not appear at all in the first term. So next we're going to put in the a term, which is 2x descending. I'll go ahead and take that all the way down, and then it doesn't appear. So I took my a and I replaced it with 2x and caused it to descend all the way down the row. So now I'm going to go and put in the second term. The second term, which is minus y, does not appear at all in the first term, but in the second term it appears once, and then it ascends twice and 3 times, and lastly it appears to the max in this one 4 times. Alright, so all we have to do to complete this is fill in the numbers, the coefficients from Pascal's triangle. So it's this one, not over here, we're over here. 0, 1, 2, 3. This should have 5 terms in it, and it does. So I'm going to put a 1 here. Already did that. There's a 4 here, squished in. Then a 6. Hope you have more room than I left myself. Then a 4. And then the unwritten 1, which I'm writing just for emphasis at this point. So when I go back and simplify that, 2 to the 4 is 16, x to the 4th. We have a 4 times 2 to the 3rd, which is 8, so we got a 32, x times a minus y. So that's going to cause the whole term to be minus 32x to the 3rd y. The next one, we have 2 squared and a 10. Then what else do we have? 2 squared and a 10. So 2 squared was 4. 2 squared is 4 times, this number is not correct. Let's see what I did. 8 times 4, 32 is correct. And this number, did I get it correct? No, that's what I was wrong. From Pascal's triangle, this number was a 6. So, sorry about that. So 2 squared is 4. 4 times 6 is going to be 24. X squared and a minus y squared is going to be a positive y squared. Then we have, on the last term, we have a 4 times a 2 and a minus, so it's going to be a minus, with the minus term is cubed, so the whole term is going to be negative x y cubed and plus y to the 4th. So that's how it turned out on this one using the Pascal's triangle and patterns, and we haven't even used the binomial theorem at all. So let me take a minute. The bell rings. I'll finish this later on part 3. Let me give you the binomial theorem and show you how it's used. The binomial theorem is a plus b raised to the n equals the summation. Notice we are always adding terms up, and you're comfortable with the summation sign. We'll start with r. It goes from 0 to n. That's the power that we're raising the binomial to. Then we have a symbol n over r, and I'll explain that in a minute. That is n objects taking r at a time. It's a number, and I'll show you how to get that number. It will correspond to the numbers that we saw in Pascal's triangle, like the 1, 4, 6, 4, 1. This will generate those numbers when you know what that means. Followed by a, and we're going to raise a to the n minus r, and we're going to raise b to the r. And this will always generate the term that you need, or the expression that you need. So what is n over r? This is an expression that tells you a coefficient or a number. That number is n factorial, which we've been working with factorials for this day, n factorial over r factorial times n minus r factorial. All right. So with that, I'm going to actually put my equipment away and get ready for my next class. I'm going to do one more example to show you how to use this binomial theorem in doing this kind of work. So, see you again on part 3. Takes a lot of time.